Section 11.1. Our objective today is I can apply the area postulate. Remember that area is always positive. And area is always units squared. Alright, so on a number line, if this is 0 and this is 1, this has a length of 1 unit. So that is one-dimensional, okay? So when we are talking about area, we are talking about something that is two-dimensional. Okay, so this is one unit wide, or 1 unit long and 1 unit wide, and so it is 1 square unit. Okay, and so then we can use the idea of square units to find the area of different figures. So remember that the area of a square is the square of the length of a side. So remember, because squares have all sides the same length, so if this is S and this is S, then the area is S squared. Okay, so area equals side squared. Okay, if we're talking about a square. The area of a rectangle equals the product of its base and height. Okay, and so in other words, area equals base times height. Because remember, when we're talking about a rectangle, normally this would be our base, this would be our height. And so area is base times height, okay? And so if the rectangle is a square, the base and the height are the same number. So that's why it's just side squared, okay? So example, find the area of a rectangle with base 5 centimeters and height 4 centimeters. Okay, and so since area equals base times height, then it's 5 centimeters times 4 centimeters. So that's 20 centimeters squared. So remember to always write area squared. Okay. Example, the area of a rectangle is 36 centimeters squared. If its height is 9 centimeters, find its base. Alright, and so all we do then is fill in our known values. So we know the formula is area equals base times height. So we know the area is 36 centimeters squared. We don't know the base, but we know the height is 9 centimeters. And so to solve for b, we divide both sides by 9 centimeters. And so we get 4 centimeters equals b. So we would say that the base is 4 centimeters. All right. Then we have what is called the area congruence postulate. Very, very important. Okay. If two figures are congruent, then they have the same area. Okay. Now we have to be very, very careful with this particular postulate, because the converse is not true. If two figures have the same area, they're not necessarily congruent. For instance, I could have one figure that's 1 unit by 6 units, and I could have, and so that would be 6 units squared would be the area of that one. And I could have another one that's 2 by 3. It is also 6 units squared, okay? But those are not congruent. So those are not congruent. So, so just because figures have the same area doesn't necessarily mean they're congruent. But if they're congruent, they must have the same area, okay? And then the next postulate is called the area addition postulate. Okay, and it says the area of a region is the sum of the areas of its non-overlapping parts. Okay, so in other words, this postulate is the one that we use when we have some figure that is an odd shape. Okay, and I really should go all the way down here. Okay, and so let's say this is 8, this is 6, this is 4, this is 4, this is 5, this is 5, this is 8, and this is 2. Okay, and so we can divide that up into 3 regions, okay, where this region is this is one region. That is a rectangle that is 4 by 5. This is another region. Okay, and that is a rectangle that is, let's see, we have 6, 5 more, that's 11, and 2 more, that's 12. So it's 8 by 12. I'm sorry, 11 and 2 more is 13. So it's 8 by 13. And then I have a third region that is again a 4 by 5, okay? And so this postulate just says that I can find each region individually and then just add them up. So region 1 is 4 times 5, or 20. Region 2 is, we said, 8 by 13, or 104. And region 3 is another 4 by 5, or 20. And so if we just add up 1 plus 2 plus 3, it's going to be 20 plus 104 plus 20, and so that's going to be 144 units squared. So the area of the whole thing is 144 units squared. So the area addition postulate allows us to break it up into parts, but again, it has to be non-overlapping parts. And there's different ways we could have divided that up. So I might have chosen instead to do something like this, okay? And this would have been a 6 by 8, okay? And this would have been, so this is 5 this way, and it's 4, 8, and 4, so that's 16. So this one would have been a 5 by 16. And then this one would have been, this is a 2 by 8. And it should add up to 144. So you can divide them up in different ways, but they cannot be overlapping.